Welcome to chemistry classes. In this video we are going to discuss about stoichiometry part 2. Okay, in this video we have to discuss here relative atomic mass and isotopes and molecular mass, and also we have to discuss here some calculation. Here we will discuss relative atomic mass, relative molecular mass, and the relation between relative atomic mass and isotopes. Also we will discuss some calculation related to this. Okay, so here first point we have to understand, we know atoms are the smallest part of any matter. Atoms are microscopic. So how to determine the mass of an atom? Atom is microscopic and it is very hard to measure its mass. We cannot use normal unit. Such as gram, milligram or kilogram. We cannot use this type of unit. To measure mass of atoms, because atoms are microscopic. We cannot measure with help of this type of unit. That's why scientists choose a standard unit. Scientists choose an atom of carbon-12. Okay, an atom of carbon-12. Atom of carbon-12 means isotope of carbon with mass 12. That is carbon-12. Okay, scientists choose an atom of carbon-12 as a standard. Okay, here atom of carbon-12 used as a standard. So here we want to measure mass of different atoms. So we will measure mass of different atoms comparing with mass of carbon-12. We will compare the mass of an atom with carbon-12. Okay, so here carbon-12 it used as a standard unit. Why carbon-12 choose a standard unit, or carbon-12 used as a standard atom to measure mass of different atoms? Here carbon-12 used as a standard because the mass of carbon-12 is exactly 12. Okay, mass of carbon-12 is exactly 12 unit. Okay, we will say 12 unit, not 12 gram, not 12 milligram, not 12 kilogram. We will say 12 unit. Because carbon-12 it contains exactly 6 proton and 6 neutron. So the mass of carbon-12 is exactly 12 unit. That's why scientists choose carbon-12 as a standard unit. Clear? Now see here, we want to measure mass of different atoms. We want to measure mass of all atoms. We want to measure different atoms. So we will compare the mass of one atom that we want to measure. Okay, so see here, imagine this is one balance. Okay, in balance we want to take carbon-12 one side, and another side we will take the mass of atom we have to measure. So here we have to take carbon-12, and here we want to take the atom that we want to measure. Okay, so here the basic concept comparing the mass of an atom with carbon-12. And we will use a special instrument to measure mass of atom. It is called spectrometer. We will use spectrometer to measure mass of atom. So how we will measure mass of atom? The mass of atom we will compare with carbon-12. We will compare with the mass of carbon-12. Which type of instrument using here? Here we will use spectrometer. We will use spectrometer, okay, to measure mass of different atoms. Clear? So here we discuss how to find mass of an atom. The mass of an atom we will find comparing with carbon 12. Okay, we will compare with the mass of carbon 12, then we can find its mass, and we will use a device, it is called a spectrometer. So look here we will consider the mass of carbon 12 exactly 12. Here we will consider the mass of carbon 12 exactly 12 unit, because it contains 6 proton and 6 neutron. Okay, so look here, when you compare the mass of magnesium, you want to find mass of magnesium. So you will compare mass of magnesium with carbon 12 using spectrometer. So you can find magnesium is twice more than carbon 12. The mass of the mass of magnesium is twice heavier than carbon 12, twice heavier. Okay, so here we know mass of carbon 12 is 12, mass of carbon 12 is 12, and magnesium is twice more mean, so mass of magnesium is 24 unit. Okay, you want to find mass of magnesium, so you will compare it with carbon 12 with help of spectrometer. So you can see mass of magnesium is twice more than carbon 12, twice more. So the mass of magnesium will be 2 times 12, so it will be 24 unit. Similarly, another example, here you want to find the mass of hydrogen. You want to find mass of hydrogen, you will compare mass of hydrogen with carbon 12 in spectrometer, and you can see mass of hydrogen is 1 by 12th mass. Mass of hydrogen is 1 by 12 heavier than carbon 12. Okay, so here 1 by 12 and mass of carbon 12 is 12. So 1 by 12 times 12, it will be 1. So mass of hydrogen is 1 unit. So here we want to find mass of hydrogen. We will compare the mass of hydrogen with carbon 12 in spectrometer. So we can see with help of instrument, we can see mass of hydrogen is 1 by 12th heavier than carbon 12. So mass of hydrogen is 1 unit. The mass of atoms, atom found with help of carbon 12. This type of mass is called relative atomic mass. Relative atomic mass means mass of an atom compared with carbon 12. Okay, mass of an atom compared with carbon 12. This mass is called relative atomic mass. Okay. So here we calculated mass of different atom comparing with carbon 12. This mass is called relative atomic mass. Relative atomic mass is represented by AR. Okay, relative atomic mass represented by AR. So relative atomic mass of magnesium is 24. Relative atomic mass of hydrogen is 1. So what do you mean by relative atomic mass? Mass of an atom compared with carbon 12. This mass of an atom called relative atomic mass. Clear? Okay, next one we have to discuss here relation between relative atomic mass and isotopes. We have to discuss here relation between relative atomic mass and isotope. So we know isotopes. Isotopes mean different atoms of same elements have same proton number but different number of neutron. Same proton number, different number of neutron. This is isotopes. Okay, so see here example for isotope chlorine 7, chlorine 35 and chlorine 37. These are two isotopes of chlorine, chlorine 35, chlorine 37. Here chlorine, their atomic number 17, mass number 35, mass number 37. So here atomic number 17. So in both case number of protons same, 17 proton. You can find number of neutron, 35 minus 17, 18. Number of neutron here, 37 minus 17, 20. So here number of neutrons are different, number of protons are same. This is isotope. Okay. And here nucleon number means same mass number. Okay, mass number 35, mass number 37. Nucleon number mean mass number. Okay, and here last one here percentage of this isotope in nature. In nature chlorine 35 available 75%. Out of 100 when you consider the availability of chlorine, 75% of chlorine is chlorine 35. When you consider the availability, total availability of chlorine, 25% of chlorine is chlorine 37. Okay, so out of 100 chlorine 35 is 75%. Chlorine 37 is 25%. So this is percentage of availability of this isotope. Okay, so here one element it exists different form. Chlorine, this chlorine existing in different form. They have same proton number but they have different neutron number. That is isotope. Okay. But the availability of this isotope in the nature it is different. So here chlorine it is one element, it exists in different form. But when you consider periodic table, in periodic table you can see one chlorine, one atomic mass. Okay, so how can you get this atomic mass? One element exists different form, they have different mass. So you want to get one mass out of all this isotope. You want to get one atomic mass. So look here how to get this atomic mass. So here to get relative atomic mass of chlorine from different isotope, this is the equation. You have to remember this equation. Okay, so here two different isotope. So here percentage of availability of this isotope times nucleon number. You have two isotope, first isotope and second isotope. Okay, so you have to add what you have to add here, percentage of availability of this isotope times nucleon number plus percentage of availability of second isotope times nucleon number of second isotope. So look here this is first isotope, this is nucleon number, first isotope its nucleon number. Okay, and this is the percentage of availability of this isotope. So according to the equation you have to do here 35 times 75. 35 times 75 plus, then you have to do same thing for second isotope. Percentage of availability of second isotope times their its nucleon number. Clear? So here this is first isotope. Okay, similar thing we have to do for second isotope. This is the percentage of availability and this is nucleon number. Okay, divided by 100, same thing, divided by 100. So after calculation you will get 35.5. So relative atomic mass of chlorine is 35.5. In periodic table you can see like this: chlorine atomic number 17, 35.5. Here fraction 35.5. This fraction coming using this calculation. If there are different isotope, so we have to do same thing. Percentage of availability of this isotope times nucleon number plus percentage of availability of second isotope times nucleon number. If there is 3 isotopes, you have to do same thing for third isotope. If there is 4 isotope, you have to continue same thing and divided by 100. Divided by 100, always same. Only you have to change over here. Okay, for first isotope, second isotope, third isotope, always you have to do nucleon number times percentage of availability of isotope. Clear? Now this is relative atomic mass of chlorine. So using this, so what do you mean by using this calculation? What you can say relative atomic mass? Relative atomic mass of an element is average mass of an atom. Average mass of an atom, average mass of its isotope, average mass of its isotope compared with carbon 12. Average mass of isotope is comparing with the carbon 12. Okay, you have many isotope, you will take average mass. This average mass will comparing with the carbon 12. That is relative atomic mass. Okay. So here relative atomic mass of an element is average mass of its isotope compared to carbon 12. That is relative atomic mass. Okay, next one we have to discuss here calculation of molecules. Next one we have to discuss here calculation of molecules. Okay, so see here we know hydrogen. Relative atomic mass helps to find mass of molecule. Relative atomic mass. We discussed already about relative atomic mass. This relative atomic mass helps to find molecular mass. Okay, mass of molecule, that is molecular mass. Okay, so see here we know relative atomic mass of hydrogen. Relative atomic mass of hydrogen 1. H2, it is molecule. Hydrogen, 1 hydrogen, it is atom. 2 hydrogen joined to form H2, that is molecule. Okay, so mass of H2, that is molecular mass. Mass of 1 hydrogen, it is 1. So H2, 2 times 1. So mass of H2, it is 2. So you can say molecular mass of H2, 2. Similarly, H2O, water molecule. Relative atomic mass of oxygen 16 and relative atomic mass of hydrogen 1. Here 2 hydrogen, 2 times 1 plus 16, 18. Here 16 relative atomic mass of oxygen. Clear? So here these are relative molecular mass. Molecular mass. Okay, so here H2O, it is molecule and molecular formula. Okay, molecular formula of water H2O. But in case of sodium chloride, we cannot say NaCl, it is molecular formula. Sodium chloride, it has 3-dimensional giant network structure. Okay, so we can say the ratio of sodium chloride, ratio of atoms of sodium and chlorine in sodium chloride 1:1, 1:1. Okay, in sodium chloride ratio of sodium and chlorine, it is 1:1. So relative formula of sodium chloride, it is NaCl. Okay, this is just formula of sodium chloride NaCl. It is not molecular formula. We already discussed giant network structure, 3-dimensional giant network structure. It is not giving molecular formula, it giving information about the ratio of atoms present. Okay, so in sodium chloride, ratio of sodium and chlorine 1:1. NaCl. It is not molecular formula. It giving just ratio of sodium and chlorine in sodium chloride. But here in water, it giving exact number of hydrogen and oxygen. In water, there is 2 hydrogen and 1 oxygen. It giving exact number of hydrogen and oxygen in water molecule. Okay, so here mass of H2O, it is molecular mass. Here we can say relative formula mass. Here in sodium chloride NaCl, it is not molecular formula, it just formula. Okay, so here mass of NaCl you can find here. Relative atomic mass of sodium, it is 23. Relative atomic mass of sodium 23. Relative atomic mass of chlorine 35.5. Relative atomic mass of chlorine 35.5. So here relative formula mass of sodium chloride 23 plus 35.5. So it will be 58.5. So here 58.5, it is not molecular mass, it is relative formula mass. Okay, relative formula giving only the ratio of atoms present. This is molecular formula giving exact number of atoms present. Clear? Here next one we have to understand here 2 laws which used in chemistry. Okay, 2 laws which used in stoichiometry. Here first law saying that the elements always react in same ratio. Elements, here these 2 laws related to chemical reaction. Here first law saying that the elements always react in same ratio. For example, we know carbon after burns it form carbon dioxide. Carbon after burns it form carbon dioxide. So imagine here 6 gram carbon after burning form or 6 gram carbon reacting with the 16 oxygen. 6 gram carbon reacting with the 16 gram of oxygen. Okay, 6 is to 16. This is the ratio of carbon and oxygen, 6 is to 16. So here we can say 12 gram carbon reacting with the 32 gram oxygen. 12 gram carbon reacting with the 32 gram oxygen. So the ratio always same. 1 is to 2. Okay, here 6 gram carbon reacting with the 16 gram of oxygen. So here we twice this mass of carbon, 12 gram carbon reacting with 32 gram oxygen. So here we can say elements always reacting in same ratio. Okay, when you increase mass of carbon, same ratio, here mass of oxygen will be increases. This is the first law. Okay, and here second law, here total mass does not change during chemical reaction. Total mass do not change. We know in a chemical reaction there is reactant and product. We discussed already in first part. Okay, so here in a balanced chemical reaction, left side always reactant, right hand side always product. Okay, so mass of reactant and product always same, do not change. Okay, mass of reactant will be equal to mass of product. Okay, that is second law. Second law saying mass does not change during chemical reaction. Mass does not change during chemical reaction mean mass of reactant always equal to mass of product. See here one example. 6 gram carbon reacted with 16 gram oxygen forms 22 gram carbon dioxide. We discuss carbon after burns in oxygen form carbon dioxide. Okay, so here 6 gram carbon, 16 gram oxygen, 6 plus 16, 22. So 22 gram carbon dioxide formed. Okay, here see here another same ratio 20 here 12 gram carbon reacted with 32 gram oxygen. Okay, 12 gram carbon reacted with 32 gram oxygen, it formed 44 gram carbon dioxide. Here 12 plus 32, it will be 44. Okay, so here the first law saying that the elements always react in same ratio. Elements react in same ratio. Here 6 gram, 16 gram oxygen, 12 gram carbon, 32 gram oxygen. So the ratio will be same. Second law saying that here mass do not change during chemical reaction. Okay, the mass does not change during chemical reaction, mean mass of reactant will be equal to mass of product. Okay, 6 gram carbon reacted with 16 gram oxygen form 22 gram carbon dioxide. So mass of reactant will be equal to mass of product. Clear? Okay, next one we have to discuss here some calculation. We have to discuss here some calculations. Okay, and here first question here 64 gram copper reacted with 16 gram of oxygen. 64 gram copper react with 16 gram of oxygen. After reacting this copper and oxygen, a black copper oxide formed. Okay, this is the statement. Based on this statement, here first one we have to calculate what mass of copper will react with 32 gram of oxygen. So here question saying 64 gram copper will react with 16 gram of oxygen. After 64 gram copper reacted with 16 gram of oxygen, a black copper 2 oxide formed. This copper 2 oxide, it is solid state. Okay, this is the question. Here based on this first one we have to calculate here what mass of copper react with 32 gram oxygen. Question saying 64 gram copper reacting with 16 gram of oxygen. So what is the mass of copper reacting with 32 gram oxygen? Simply you can calculate this. Here copper and oxygen. According to this question 64 gram copper reacting with 16 gram of oxygen. So here what mass of copper reacting with 32 gram oxygen? So you have to find this is unknown value. You just cross multiply this. Okay, so here 16 times x equal to 64 times 32. Clear? So unknown value x will be 64 times 32 divided by 16. So you can cancel this. Here it will be 2. 32 divided by 16, it is 2. 2 times 64, it will be 128. So answer is 128 gram. Okay, so here mass of copper reacting with the 32 gram oxygen is 128. 128 gram copper will react. Clear? Okay, based on same question, you have to calculate what mass of oxygen will react with 32 gram copper. Same question, here you have to calculate mass of oxygen reacting with the 32 gram copper. We can use same method. Okay, here copper. Here according to this question 64 gram copper reacting with the 16 gram oxygen. Here you have to find mass of oxygen reacting with 32 gram copper. Okay, so we will do same method. We will cross multiply this. So here 64 times x equal to 32 times 16. So x will be 32 times 16 divided by 64. Okay, here after cross multiplication, 64 times x equal to 32 times 16. Then x will be equal to this. So here you can say 32 divided by 16. 32 divided by 64, it will be 2. 16 divided by 2, it will be 8. So 8 gram. 8 gram. So here mass of oxygen will be 8 gram. Clear? So you can use same method to calculate this. Okay, here next question. What mass of copper 2 oxide will be formed in question B? We discussed question B. In question B we discussed 32 gram copper giving or 32 gram copper reacting with 8 gram oxygen. We discussed already 32 gram copper, 8 gram oxygen. So here based on that, what mass of copper 2 oxide will be formed in B? In B mean 32 gram copper reacted with 8 gram oxygen. What mass of copper 2 oxide formed? So look here, this is copper reacted with oxygen formed copper oxide. Okay, so we discussed already 2 law, mass of reactant always equal to mass of product. Okay, so mass do not change during chemical reaction. Mass of reactant always equal to mass of product. So here we discuss in question B 32 gram copper reacting with 8 gram oxygen. Okay, so what will be the mass of copper 2 oxide? It will be 32 plus 8, so it will be 40 gram. Okay, it will be 40 gram because mass of reactant do not change during chemical reaction. Clear? Okay, based on this last question, how much copper and oxygen react to get 8 gram copper oxide? To get 8 gram copper oxide, 8 gram copper oxide, what mass of copper and oxygen should react? Based on this question, we know 64 gram copper reacting with 16 gram of oxygen. 64 gram copper reacting with 16 gram of oxygen. Mass of reactant always equal to mass of product. So mass of copper 2 oxide formed 64 plus 16. So it will be 80. Okay. So 64 gram copper reacted with 16 gram of oxygen. It will be 80 gram. 80 gram copper 2 oxide. The question asking to get 8 gram copper oxide, what mass copper and oxygen should react? Okay, so you just check this here. 80 changed to 8. How 80 changed to 8? 80 divided by 10. 80 divided by 10, it is 8. Clear? So you have to make this also 16 divided by 10. Here 64 divided by 10. We know this already. 64 gram copper reacted with 16 gram oxygen, 80 gram copper 2 oxide formed. Here we need only 8. So how 80 changed to 8? 80 divided by 10, that is 8. So also we have to do here 16 divided by 10, 64 divided by 10. So you will get 64 divided by 10, it will be 6.4. Here 16 divided by 10, 1.6. So here 6.4 gram copper reacted with 1.6 gram oxygen, 8 gram copper 2 oxide formed. Okay, so this is the answer. Okay, 6.4 gram copper reacted with 1.6 gram oxygen, 8 gram copper 2 oxide formed. So you have to check like this. 80 changed to 8. How 80 changed to 8? 80 divided by 10, that is 8. So also we have to do same thing. That is the answer. Clear? Okay, next one we have to do here some calculation related to percentage. We have to do some calculations related to percentage. So here first question, we have to find the percentage of oxygen in sulfur dioxide. Find the percentage of oxygen in sulfur dioxide. So look here, sulfur dioxide, this is the formula of sulfur dioxide. Relative atomic mass of sulfur 32. You can check periodic table, you can find it. Relative atomic mass of sulfur 32. Relative atomic mass of oxygen 16. Relative atomic mass of oxygen 16. So here molecular mass of sulfur dioxide you can find 32 plus 2 times 16. So it will be 64. Okay, here 32, this is also 32, 32 plus 32, 64. So here you have to find percentage of oxygen. Find percentage of oxygen in sulfur dioxide. Mass of sulfur dioxide 64. Okay, so what is the mass of oxygen in sulfur dioxide? Relative atomic mass of oxygen 16. Here 2 oxygen in sulfur dioxide, 2 oxygen. So here 2 times 16, it will be 32. So mass of oxygen in sulfur dioxide 32. Okay, so these two value you have to find. What is the question asking? You have to find percentage of oxygen in sulfur dioxide. So sulfur dioxide mass is 64, mass of oxygen is 32. Here relative atomic mass of oxygen 16, 2 oxygen here, so 2 times 16, 32. This atomic mass you will get from periodic table. Okay, no need to memorize it, you will get from periodic table. Now you have to find the percentage of oxygen. So here you can do like this. Mass of oxygen in sulfur dioxide divided by molecular mass of sulfur dioxide times 100. Okay, so what is the mass of oxygen? Mass of oxygen 32 divided by molecular mass of sulfur dioxide 64 times 100. Okay, so here 32 divided by 64, here it will be 2. Okay, so 100 divided by 2, answer will be 50. So 50 percentage. So what is the mass of oxygen in sulfur dioxide? 50 percentage. So answer is 50 percentage. Okay, so this is the equation, mass of oxygen divided by mass of sulfur dioxide into 100. Do not take here 16. When you take here 16, your answer will be wrong. So do not forget to multiply 16 times 2 because here 2 oxygen, sulfur dioxide, SO2. 2 times 16, you have to remember 2 times 16, then it will be 32. You have to use here 32, not 16. So answer will be 50 percentage. Okay, next one we have to discuss here calculation of percentage purity. We have one impure sample. We want to find its percentage purity. Okay, to find percentage purity of a sample, this is the equation. Mass of pure substance. You have one sample, it is impure. So impure sample which contain impurity and pure substance. Pure substance and impurity that mixed, that is impure sample. So you want to find the percentage of purity, percentage of pure substance present in it. That is percentage purity. To find it, percentage of pure sample, percentage of pure substance divided by total mass. Mass of pure substance divided by total mass into 100. This is the equation to find percentage purity. You have one impure sample, you want to find percentage purity. To find it, the equation is mass of pure substance divided by total mass of substance into 100. Okay, so see here, based on this one question, here impure copper, impure sample of copper is refined. After refined, 20 tons sample is refined. after refined 18 ton pure sample, pure copper is obtained. Impure sample it is 20. Impure sample it is 20. Copper with the impurity it is 20 ton after purification, after refining 18 tons copper formed. So what is the percentage purity of copper? I told you you have to use this equation, mass of pure substance, mass of pure copper. What is the mass of pure copper? 18 tons. 18. Okay. What is the mass of sample? What is the total mass? Total mass mean impure sample or impurity plus pure copper. This is total mass 20. So 18 divided by 20 into 100. 18 divided by 20 into 100. So you will get 90 percentage. 90 percentage. So this is the percentage purity of copper in this sample. 90 percentage. Clear? Okay, based on this next question here, how much pure copper will be obtained from 50 tons of impure copper? We have 50 tons of impure copper. So this 50 tons impure copper give how much ton pure copper? So based on first question, we found here 20 ton sample which contain only 90 percentage pure copper. So in this sample only 90 percentage pure copper obtained. Even it is 20 ton, 50 ton, 100 ton, it obtained 90 percentage pure copper. The percentage purity is 90 percentage. 90 percentage pure copper, rest 10 percentage impurity. Okay, so you have here 50 ton. You have here 50 ton impure sample. Okay, from 50 ton impure copper you will get 90 percentage pure copper. So here 90 percentage mean 90 divided by 100. This is 90 percentage. Okay, so here 90 percentage of 50. 90 percentage of 50 mean 90 divided by 100 times 50. That is 90 percentage of 50. 90 percentage of 50 mean 90 divided by 100 times 50. When you solve this, you will get 45. You will get 45 ton. So here you have 50 ton impure copper. You will get 45 ton. You will get 45 ton pure copper. Rest will be impurity. So here you have to remember, in this question we found the percentage purity is 90 percentage. So when you take impure sample, its 90 percentage will be pure copper, rest will be impurity. So you have here 50 ton impure copper. So out of 50 ton, 90 percentage pure copper, rest impurity. 90 percentage mean 90 100. Okay, 90 percentage of 50 mean 90 divided by 100 times 50. This is the way to find percentage. Okay, so the answer is 45 ton. Clear? So these are the things we have to discuss in this video. Okay, so rest of the part we will discuss next video. So thank you for watching this channel.